Alright, part 3 here. Got just a couple more problems here to try. So we're going to start off here with 29. X squared minus 6x plus 8 is less than 0. So the directions say to solve and write it in interval notation. So what we're doing here when we have one variable is we're going to first start off by trying to factor. So we really care about here finding the x-intercepts. This is going to factor as x minus 4 and x minus 2. So here we can see that our x-intercepts would be at 4 and 2. So let's make a little rough sketch of the graph. 1, 2, 3, 4, 5. So we're crossing at 2 and 4. Notice that the graph here is positive in front, so it's going to open upward. And then we're using this to try to figure out, well, where is it negative at? Where is it less than 0? Well, we can see from the graph that it's below, it's negative between these two values down here. Right? So then in interval notation, we would write that as saying, well, it's from 2 to 4, between 2 and 4. Since it's strictly less than instead of less than or equal to, you're going to use parentheses. If we had equal to's here, these would be in brackets. Okay, there's one down. 30. Negative 2x squared minus 20x minus 42 is less than 0. The first thing I'm going to do here is divide all of these pieces by negative 2, since they're all even. So x squared plus 10x plus 21. When you divide by a negative, you've got to flip your sign. So this is going to factor, again, x plus 7 and x plus 3. So I have intercepts at negative 7 and negative 3. So there's negative 3, there's negative 7. In this case, the part that I was graphing was right here. So it opens up again, like this, and I'm looking to see where is it above 0. Will that be from here over and from here over? So from negative infinity to negative 7, and from 3 up to infinity. Okay, another one down. 31. X squared plus 8x is less than negative 16. First thing you should be doing here is doing the set equal to 0. So moving the 16 to the other side. And we can factor it. And then set the factors equal to 0. So both of these are going to be x equal to negative 4, which tells you that your vertex is actually going to be on the axis here. So 1, 2, 3, 4. We have one intercept, and it's opening up. So whenever your thing factors as a perfect square, or whenever you get a perfect square trinomial, your vertex is going to be on the x-axis. It's going to do something like this. So we're looking to see, where is it less than 0? Well, where is it below? Well, it's not below. So this one has no solution, because the graph is never below, no matter what x value you plug in. Okay, 32. We have 2x minus 3 squared plus 2. Okay, so let's make we don't have to find zeros here, we can just make a sketch of the graph, I think. So we're going up 2 and to the right, 3. So this is the part that tells you to go up, this is the part that tells you to go right. That's your vertex. It's positive, so it's going to open upward. And then we're looking to see, where is it above 0 at? Well, where is it above 0? Everywhere. So this one has infinitely many solutions, and we write that in interval notation as saying from negative infinity to positive infinity. So it's above the axis everywhere on the graph for all of the x values. Right. And then finally, 33. We have x minus 3, x plus 1 and x plus 1/2 is less than 0. So x would be 3, -1, and -1/2. Okay, so they had this one factored for us already, which is nice. So we have one at -1, one at -1/2, and one at 3. Alright, so in this case, you're not going to see a problem like this on the test. I'll just go ahead and tell you. But again, I do want to show you how to do it because it's pretty neat. We're going to make a sign chart here. -1, -1/2, and 3. And what I want to do is I want to plug in a value that's in between two of these things. I'm going to plug in the easiest one I can think of. Plug in 0. So if you plug in 0, well, 0 minus 3 is negative. I don't really care about the value. 0 plus 1 is positive. Again, I don't care about the value. And 0 plus 1/2 is also positive. So a negative times a positive is going to end up being a negative number. So between -1/2 and 3, our graph is below the axis. It's negative, so it's going to do something like this, roughly. Then what we know is, well, each of these points only occurred once, so it's going to cross every time it touches the axis. It's going to go through here, it's going to go through there, and it's going to go through there, like so. So we never looked at a graph like this before, but we can use a little bit of knowledge here to figure out what the signs look like. So we want to see, where is it less than 0 at? Well, from -infinity up to -1, and also from -1/2 up to 3. Again, this problem is not going to be on the test where you're doing a sign chart and having to know a little bit about the graph. You won't see anything like that, but still a cool skill to know. Alright, a couple more questions here. This is the last page from the review. So we got a couple of graphing problems up here to do first. So let's go ahead and get those done. So in this one, we're shifting our graph to the right 3 and up 1, and then opening upward. So we're going to go over 1, up 2, over 2, up 1, 2, 3, 4, 5, 6, 7, 8. Then do the same thing on the other side. This is our axis of symmetry here. Notice that it's less than or equal to. The equal to means that we're going to have a solid line. And the less than part tells us to shade below the vertex. So that would be all of this mess outside, like so. Okay. Alright, in this one though, we have to do a little bit of work here because they don't give us vertex form. So we have to go through and try to first figure out where's the vertex at. So in this case, I'm going to solve this by completing the square. X squared plus x minus 3. So take half of this, which would be a half, and square it, which would be a fourth. So I really added 2 times a fourth would be a half. So I'm going to take away a half from the outside. So then this will factor as x plus 1/2 quantity squared minus 3.5. So then I'm shifting my graph to the left a half and down 1, 2, 3.5. And then I have a vertical stretch of 2, so I'm going over 1, up 1, 2. Or over 1, up 1, 2. Okay? Since it's just greater than, I'm going to do a dotted line. And I could find some more points here if I really wanted to, but I'm sure you guys are probably tired of watching this if you are, so I'll try to do this a little bit quickly. So this is a dotted line here, and it's greater than, so I'm going to find the vertex and shade above it, like so. Okay. One final look here. This one is a system. Notice that the bottom equation isn't solved for y. So the first thing we want to do is get it solved for y. So I'm going to move the y to the other side. And then move the 5 to the other side by adding it. and then divide both sides by a negative. When you do that, you got to flip your sign. So we have y is less than negative 2x minus 5. 1, 2, 3, 4, 5. And the slope is negative 2. So this is the line that we're going to go in and graph. And it's just less than, so we're going to do a dotted line. And we're shading less than, so that would be below. I'm going to do so really lightly here because I have another line to go back and graph. We also have a parabola part here. So again, I'm going to solve this by completing the square. Square plus 4x minus 4. Half of this would be 2. Squared would be 4. But I really just put in a sorry, excuse me. Put in a negative 2 times 4, which is negative 8. So to balance it, I'm going to have to add 8 to the end. So this will factor as negative 2 times x plus 2 quantity squared plus 4. So we're shifting it left 2, up 1, 2, 3, 4. And then we're opening down, going over 1, down 2, over 2, 1, 2, 3, 4, down 8. And it is going to be a solid line. And since it is less than, it's going to be shaded below. And the solution to the system would be where those two parts overlap at. So I'm going to go back and shade that part in darker than the rest of it, to show that the solution is just this part here where the shading overlaps. Okay, so there's a couple of graphing problems done. So on to, it seems like I'm wasting a lot of paper here, which I kind of am, so that's okay though. 37, we have the system y equals x plus 3 quantity squared minus 1, and y equals x plus 4 quantity squared minus 2, like so. Alright, so to solve this, we're first going to have to get it into standard form, so I need to multiply some stuff out. So here this top equation is the same thing as x squared plus 6x plus 9 minus 1, which will be x squared plus 6x plus 8. This one here on the bottom is x squared plus 8x plus 16 minus 2, which will be x squared plus 8x plus 14. So to solve a system, we're going to do it by substitution. So these are both equal to y, so therefore they must be equal to each other. Alright, so then subtracting x squared from both sides, we see that the x squareds are going to cancel out. And then subtracting 6x from both sides, I get 8 equals 2x plus 14. Subtracting 14 from both sides, I get negative 6 equals 2x. And dividing by 2, see that x equals negative 3. So notice this is just an x value. And when two equations are going to cross, they're going to cross at a point. I need to find the y value. So to do that, I'm going to take my top equation here and go back and plug in the x value that I found. So y would equal 0 squared minus 1, which is just negative 1. So the solution to the system is the point negative 3, negative 1. In this case, since it occurred to the whole number, I probably could have found it a little bit faster by making a graph, but that's a risk I wasn't willing to take, especially on camera after recording 10 minutes already. So looking at 38, we have another system. This one's going to have more than one solution though, I think. Y equals 2x squared plus 4x plus 1. So again, we're going to solve it by setting the two equations equal to one another, since they're already in standard form. So moving the 2x to the other side, I'm going to get x squared. Moving the 4x to the other side, I'm going to get 3x. Moving the 1 to the other side, I'm going to get 2. Which will factor as x plus 1 times x plus 2. Setting the factors equal to 0. I see that my x values occur at -1 and -2. So then I want to find y values for each of those. So I'm going to take the top equation, go back and plug in what x is equal to. So -1 squared is +1 times 3 would be 3. Minus 7 plus 3, which is -1. So one of my points on my system would be the one at -1, -1. Then if I take the top equation and I go back and plug in the other number I found, -2, well, -2 squared is 4 times 3 would be 12. And 12 minus 14 is -2, plus 3 is +1. So -2, 1 is the other point where they cross. So I have two solutions here, -2, 1 and -1, 1. Or -1, -1. Okay. So that's kind of it for the quadratic part. The only thing left really is to look at some of the complex stuff. So number 1 on the complex part there at the end of the worksheet, we have the absolute value of 3i. So recall that we can graph a complex number by putting the complex part on the y-axis and the real part on the imaginary axis. So 3i would be like going up 3 units on the imaginary part on the complex part. Or really, I guess I should call this imaginary rather than complex. So on the imaginary axis we go up 3, and then absolute value measures the distance the number is from 0. Well, the distance from the origin here is 3 units, so this absolute value of 3i would just be 3. Okay, next we have 10 plus 9i in the absolute value bars. Same idea here. We're going over 10 and up 9. And I want to know how far apart is this from the origin. What's this distance? So notice that I can do this by dropping in a triangle. So the height here would be 9, the base would be 10, and then the Pythagorean theorem, 9 squared plus 10 squared would equal x squared. So 81 plus 100 would equal x squared. So then x would be the square root of 81 plus 100. And I can ignore the fact that this has two solutions, a positive and a negative, because I'm measuring distance. So distance can't be negative, so I'm just going to have one solution here, the square root of 181. Alright. The next couple problems are super easy. Like number 3 here, we have -8i plus -1 minus 6i plus 2. The idea here is we're going to take the complex parts and add those together. -8 minus 6 be -14. Then take the real parts and add those together. -1 and 2 would be 1. So my answer would be 1 minus 14i. Simple as that. Number 4, same idea here. -7 plus 3 would be -4. -5i plus 8i would be 3i. Okay. Number 5, we have -7 plus I squared, which is the same thing as -7 plus I times -7 plus I. So first by first, outer by outer, inner by inner, last by last. So notice that 49 minus 14i plus I squared is what we come out with. But then recall that I squared is the same thing as -1. 49 minus 1 would be 48 minus 14i. and that would be where you would stop. Okay, rather than waste another whole sheet of paper, I'm just going to finish up these on the actual paper itself. So again, distributing here, -3 and -7 is 21. -3 and I, -3i and -7, and then -3i and I. Alright, and then recall again that I squared is the same thing as -1. And I combined my i's. So -3 and -1 would be +3. So I'd get 24 plus 18i. Okay. 7 here. Notice we have i's in the bottom. That's bad. So we're going to multiply by the conjugate of the bottom, like so. Lots of distribution here to go through and do. These problems are not my favorite. So -2 and 5 would be -10. -2 and 7i, -14i. -9 and 5 would be -45i. And -9i and 7i would be -63i squared. So there's your top. On the bottom, because we're multiplying by the conjugate, we really have to worry about first by first and last by last. Because the outer by outer and the inner by inner will, by definition, cancel themselves out since they are conjugates of one another. So then on top, we're going to get, well, I squared is -1. So that's really like a +63. If I combine that with this -10 over here, that's going to give me 53. Then -14 and 45 would be -59i. On the bottom, this is like a +49. If I add that to 25, that would be 74. So I'd get 53 minus 59i over 74. Okay, so just working that out. Number 8 here, again, we're going to multiply by the conjugate, -10 plus 6i on top and bottom. So on top, we're going to get -100i plus 60i squared. And on the bottom, I'm going to get 100 minus 36i squared. So then I squared is -1. Minus 100i, we can't do anything with that. And then this would be a -1, place that positive, 136. And the only other thing really we can do here is all of these numbers are divisible by 2, or actually all divisible by 4, but I don't know what 136 divided by 4 is, so 50i over 68, so -15 minus 25i over 34, and I think that's as far as it goes. So -15 minus 25i over 34 is the answer to number 8. This one's really quick here, so just going out of order. The conjugate, remember you just changed the sign between them. And very last problem here, I to the 723rd power. So recall that I is just I. I squared we said was -1. I to the third is -I. And I to the fourth is +1. And after that, the pattern starts to repeat. So if I divide 723 by 4, and I look at the remainder, I can assign it a value here. So 4 goes into 7 one time. 4 goes into 32 8 times. 4 goes into 3 no times. So 3 is my remainder, which corresponds to I to the third. So I to the 723 is the same thing as -I. Alright, so there's an hour and a half of your life gone. If you've watched all 3 videos, hopefully they helped you out though. If you have any questions, feel free to leave a comment below. Otherwise, good luck.